Hello everybody and welcome to the review of trigonometry. So if you could go ahead and get out your unit circle sheet, either the one I gave you, and if we haven't met yet in person, then if you could just go ahead and pull it up on Schoology and have it from Schoology and have it handy. Another thing that's on Schoology that will be helpful today is the Trig Identities sheet. So you might want to keep that around as well. So if you wanted to take that out, that'll be helpful on your homework later today. Otherwise, let's go ahead and get started. So, once again, recall the unit circle. You guys have one in front of you, and you'll be able to use it on your tests and quizzes. Biggest thing to remember is if we're looking for cosine values, those are your x, and your sine values are your y values. Today, we're going to be solving for solutions over the interval 0 to 2 pi. Okay, so what we are looking for is an angle. Okay, so we're solving the trig equations. We're saying what angle gives me that whatever answer we're looking for. Okay, in order to solve trig equations, the first thing we need to do is get the trig function all by itself. So I would subtract 1 to the other side. Then I would go ahead and divide both sides by 2. And then if you have your unit circle handy, what we're doing is we're looking for what angle or what sine value gives me an answer of -1/2. So first of all, I'd ask myself, is sine an x or a y value? Sine is our y value. And where are your y values on your unit circle? Negative. Well, in quadrant 1, they're positive. In quadrant 2, they're positive. Quadrant 3, we are negative. And quadrant 4, Ivy, there we go. 4, we're negative. So we're looking in these two quadrants for a y value of -1/2. So what we do is go to our unit circle, and we look for a y value of -1/2. So there's one, and then you should be able to just go across. And there is the other one. So my answer, what angle gives me this answer? 7 pi over 6 and 11 pi over 6. There is example 1A. Example 1B, it's a little bit different. We got secant. Okay, secant is not directly on our unit circle, so we need to go ahead and convert it into sine, cosine, or tangent. And so secant is the reciprocal of cosine, so we'd have 1 over cosine of x equals 2 root 3 over 3. And now I don't want 1 over cosine, so what I'm going to do is I'm going to flip both sides. So I have cosine of x equals 3 over 2 root 3. And now this is not a value that's on my unit circle, so what I would do is rationalize. Okay, multiply top and bottom by square root of 3. So now I have cosine of x equals 3 root 3 all over 2 times square root of 3 times square root of 3 is the square root of 9, which is 3. So 2 times 3 is 6. Then you just need to check, can I reduce this? This 3 and this 6? Yes, I can. This is 1 and 2. So what we are really looking for is where our cosine is square root of 3 over 2. Cosine on our unit circle is our x or our y value. It is our x value. And I'm looking for where it's positive. So where our x value is positive. Quadrant 1, everybody, both our answers are positive. Quadrant 2, it's negative. Right, my x values are negative, and also we're negative in quadrant 3, but in quadrant 4, my x values are positive. So I am looking for answers in quadrant 1 and quadrant 4, okay, to figure out what angle I would plug in there to get an answer of square root of 3 over 2. So going back, I don't have my unit circle right here. Cosine, we were looking for square root of 3 over 2? Yes. So cosine's my x. Where do we have an x value of square root of 3 over 2? I have one here. And then I can just go right across to my quadrant 4 and here. So my answers for this one are pi over 6 and 11 pi over 6. So x equals pi over 6 and 11 pi over 6. And I guess I didn't say this earlier, but if you notice, it says find the solutions over the interval from 0 to 2 pi. So we're looking around the unit circle. And this also tells me that we got to be in radians. If it wanted in degrees, it would say 0 to 360 degrees. Okay, but most of the time in calculus, we work in radians. So there is that. All right, the next one. This one is a factored form. It's already factored for us. So we would just go ahead and set each part equal to 0 and solve. So I got 2 cosine of x minus square root of 2 equals 0, and tangent of x minus 1 equals 0. Why don't you guys go ahead and pause this answer and find the solutions. Now that you've paused it, we got 2 cosine of x equals square root of 2. And then we got cosine of x equals square root of 2 over 2. So my cosine is positive in quadrant 1 and quadrant 4. If you look for square root of 2 over 2, it is your 45-degree angle. So x is equal to pi over 4. And then in quadrant 4, it would be 7 pi over 4. Okay, there are my answers for that one. Then I would also go ahead and solve the other equation. So I just go ahead and get tangent by itself. There's a few ways to tackle tangent. You could think about this as really sine over cosine of x, which I think is maybe the easiest way. We have sine over cosine. So you'd have to say, what angle would my sine value over my cosine value give me an answer of 1? Well, anytime I divide, in order to get an answer of 1, the numerator and the denominator need to be the same number. So this is really saying, where are my sine and cosine values the same? Okay, so where are sine and cosine the same? That's going to be, they're not the same here, but here they are. So one answer is pi over 4. Then where else is tangent positive? This one's a little tricky. Order pairs. We got positive, positive here. This is negative, positive. This would be negative, negative. And then this would be positive, negative. So tangent sine over cosine. So we're positive here. And if I did sine over cosine, I'd have positive divided by a negative. So that would be a negative answer. So don't include that quadrant. I'd have a negative over a negative, which is a positive. So I would look in quadrant 3. And then this would be a negative tangent. So if I go to quadrant 3, the way I would look at my unit circle, I'm here, just go straight across. My other answer is 5 pi over 4. So 5 pi over 4. That's one way to find your tangent. The other way might be easier for you if you don't feel comfortable with logically thinking it through. You can always use your calculator. In order to solve for an angle on my calculator, we always go tangent inverse, okay, on both sides. Because the tangent inverse and tangent cancel. So I need to type in my calculator tangent inverse of 1. Okay. This one, it's actually easier to leave your calculator in degrees whenever you're doing the inverse. Okay. And we'll convert it into radians. So we gotta change our mode because I am in radians. So mode, changing it to degrees. And then I would go ahead tangent inverse of 1. And it tells me one answer is 45 degrees, which is what we got, okay? You can convert them into radians one of 2 ways. Calculate, there we go. You could look at your paper, because you are given a paper copy, and say, oh, here's 45 degrees. It's pi over 4 in radians. However, if you don't want to do that and you don't want to use your paper, the way you do it from last year is if you have 45 degrees, in order to convert into radians, you multiply by a conversion factor. The conversion factor we use is that 1 radian of pi is equal to 180 degrees. We use this fact. So we put, in order for our degrees to cancel, you got to have 180 in the bottom. And you put pi on top. Those cancel. So you have 45 pi over 180. And then in order to simplify or to find the answer, you do 45 divided by 180. You can reduce it on your own math frac, and it will reduce it to 1/4, which gives us our pi over 4. And then just don't forget to find your second answer. You know it's in quadrant 3. So if you went all the way over here, you'd know we had to go a distance of 45 degrees to get this answer. So that means here we have to go a distance of 45 degrees. So you would do 180 plus 45, which gives me 225. And if I were to convert that into radians, I would get 5 pi over 4. So that gives me my other answer. Sorry, this answer, I did not end up doing most of my work on the actual example. All right, so there is that. So For this problem, it's actually all of these answers. Notice there's a repeat of pi over 4, so I don't need to write it both times. So I just write it once, pi over 4, and then I'm going to go in order. So I do 5 pi over 4 and 7 pi over 4. So these are all of my solutions, for example, 1C. Then there is trig identities. I have a trig identity sheet on Schoology, and I think I already pointed that out to you earlier. It is right here. That will be helpful on your homework. There is a true-false section on your homework. Here's your worksheet for today. So if you go ahead and look at it right here, basically what it is look it up and see if it's true or false. Is it on the sheet? Can I rearrange it in some way, shape, or form to make it happen, or to have this fact, and then say if it's true or false. Then, oh shoot, I want to have example 2. I'm going to go ahead and it says use the trig identity, show that the following are true. These are our trig proofs. Okay, when we're doing trig proofs, our goal is to take the more complicated side and simplify it to the simpler side. So this left-hand side is more complicated. Some tools to use while doing some trig proofs. This is not going to be all of them, but these are some of them. One thing you can do is simplify. The other thing you can do is factor. The other thing is rewrite everybody to be in terms of sine and cosine. Sine, cosine, sometimes tangent's helpful. Okay, usually we stick to sine and cosine. So simplify, factor, rewrite, those are some tools that we want to try. Okay, so if I go ahead and start out here, looking at this first one, the left-hand side is more complicated. They're already in terms of sines and cosines, and there's really no simplifying that can happen, but I can factor. So we're going to factor on this one. If I look at my numerator, I can take out a cosine. So I got cosine of x. And then I have sine squared of x plus, if I had a cosine cubed and I took one out, I now just have cosine squared all over sine of x. And we were trying to show that this equals cotangent of x. Sorry, my handwriting is kind of messy today. So from here, I'm going to simplify. Using our trig identities, one that we talked about in the unit circle video, is what is sine squared plus cosine squared? It is 1. So I am left with cosine times 1, so I just have cosine over sine of x. And what is cosine over sine? Cosine over sine is cotangent of x. Check. All done with example 2a. Then our next trig proof is right here. So what do we got to do? I could try and factor again. If I look at the left-hand side, the more complicated side, I don't see anything that they share, so I can't factor anything out. There is no simplifying. So what I'm going to do is I'm going to rewrite everybody into terms of sines and cosines. Tangent is sine of x over cosine of x. What's going on here? Sorry. There we go. It's tangent sine of x over cosine of x times just cosine. It's already written as cosine. Plus cosecant. Remember, cosecant is 1 over opposite first letter, so 1 over sine times sine squared of x. And we were trying to show that that equals 2 sine of x. Now that I've rewritten, can't factor anything, but I can simplify. Those cosines will cancel, so we'll have sine of x plus sine squared over sine, simplifies to be just sine. And now if I have sine plus sine, it's like x plus x. What's x plus x? It is 2x. So I have 2 sine of x equals 2 sine of x. Check. We are done with that proof. So those are some trig proofs. You can use the trig identity sheet on Schoology to help you out. Like I said, that pulls up. And I don't have it pulled up, I lied. But you can pull it up and use that to kind of help you remember some things. Otherwise, on your homework, I want you to be aware of this. Pick 3 out of the 6 identities below to verify. So pick 3 of them. You don't have to do all of them, and then you can put your work down here. okay? There's more than one way to get it to simplify, so it doesn't have to be the same as your friends, okay? So there is that. Just notice that there's only 3. Okay, then we are going to go ahead and skip example 3. It's not on our worksheet and we don't see it again, so we're not going to worry about it today. So we're skipping example 3. No need to worry about that. Then your homework is the trig review worksheet, which I kind of went through. So the first part is solving equations, just like the first part of our notes. And then this is a little true false. So like I said, pull up the trig identity sheet and use it to try and figure out if it's a true or false statement. And then lastly, you got 3 trig proofs. So give them a good try your very best, and if you have questions, let me know. Otherwise, that is it for today, and you have a great day.